Hi everybody. Today we are working on limits numerical approach, which means we're going to have some tables there. Just to really quickly review something here from previous videos that we did for graphical approach to limits. This is, for example, a is x, and then I have a graph like this. So, if I'm asking what is f of a, which means when x is equal to a, then what is the y value there? There is no y value for this a because it's a whole. It's undefined point. It's not a defined point. So we're going to pick something arbitrarily close if I'm asking limits. If I'm asking just a point, it's undefined, then I'm going to say f of a is equal undefined. I don't have a y value there for a. But if I ask limit x approaches a from the left, you stop here, that's arbitrarily close. Limit x approaches a from the right, you stop here, that's arbitrarily close from the right side. Then you can say, for example, that was b, so you can say you round it up when you go to arbitrarily close, and it's going to be b anyway, but it's not a defined point. Based on what you have seen so far, does f of a have to be defined? No, my f of a, for example, this is f of a, it's not defined, it's a whole. F of a means a y value. In order for the limit x approaches a f of x to exist, no, f of a does not have to be defined in order for the limit to exist. Draw and explain two different graphs to justify your reasoning. In both graphs, f of a should be undefined. In both graphs, f of a should be undefined, but in one graph limit exists and in the second one limit does not exist. So we're going to make f of a undefined either way, where one limit exists, one limit doesn't exist. So I'm going to make a graph, for example, that's a, and they said the f of a is supposed to be undefined, so it's a whole, and that's f of a, for example, that's x equal a, and that is the y value for this a. And my graph goes like that. It's gonna go something like this. So in this case, the question is if the limit exists. The limit does exist even if f of a is undefined. When I approach a from the right side, I'm getting arbitrarily close here. X approaches a from the left side, I'm getting here arbitrarily close. It's going to round it up to f of a anyway. So the limit does exist. So I'm going to say limit f of a is undefined, but limit x approaches a of f of x exists because limit x approaches a from the left of f of x is equal limit x approaches a from the right of f of x. So yes, the limit does exist. Now let's draw another thing where limit does not exist and fa has to be undefined. So I'm going to make this f of a again, and this f of a has to be undefined, for example. And then I have probably another one. Let's try that. And this is pretend that's b. Okay, so in this case, they said the f of a is undefined. You see, the f of a is undefined. It's still the whole. So, and I can say, is the limit exist? No, the limit does not exist because x approaches a from the left is arbitrarily close, and we round it up to a, f of a. And limit x approaches a from the right, that's a defined point, but the y value is b. So limit does not exist. Limit x approaches a of f of x does not exist because limit x approaches a from the left of f of x is not equal limit x approaches a from the right, which is this one. You see, one is f of a, another one is b. So it does not exist. You can make it up the way you want it. Below is the table of values of exponential function. Use the table to find the limits that follow. Now this is numerical approach to limits. Now let's try how we're going to do this. They said limit x, you guys check the table. The table, this side is all negatives, this side is all positive, and these are all my y values. Limit x approaches negative infinity of f of x. X is approaching negative infinity. So this is x, negative infinity. For example, if I draw this, you know that's negative infinity when we go in this direction. So if I'm going in this direction, that's negative infinity, and I'm going in this direction. Then what is the y value when you're going in this direction? Then you're going to check the last two numbers. Do you see? There is a huge difference. I know both of them are positive. So I'm approaching some positive y. But if you check the difference, this is 33, this is 530. It's a huge difference. When the difference is really big, like this one, then it means you're approaching positive infinity. Because if this is 513, you're going to go, I don't know, 1000 something. So it means I'm approaching positive infinity, and these are all positive numbers. Limit x approaches -3 from the left and right both of f of x, because they didn't mention anything. So this is -3. X approaches -3 from the right, x approaches -3 from the left, and you know their y value is 9. It's not a hole, it's a defined point. It's a closed circle defined point. So the answer is 9. Limit x approaches 1, again from left and right of f of x, that's 1. I'm going to go x approaches 1 from the right, x approaches 1 from the left, and you know the y value is 1.5 because it's a defined point. I do have a y value for it. Limit x approaches positive infinity. Positive infinity means I'm going, for example, positive infinity, I'm going in this direction. This is where I'm going, positive infinity. What is the y value? Check the two numbers. Is there a difference, a huge difference? I don't think so. There is a huge difference like the one we had here. I know it's going positive, but not that much difference. This is 1.125, this is 1.002. So what are you going to do when there is not a huge difference like that one? Then you just pick this last number and round it up, which is 1 in this case. Okay, let's go to the next question. Below is the table of values of rational function. Use the table to find the limit that follow. Now again, limit x approaches negative infinity of f of x. So I know my x's are all this, and these are all negative infinity in this direction when I'm going. So what is the y value? So you check again the last two. Do you see? It's a huge difference, right? But it's not something like it's decreasing. It's not going to infinity positive. You understand that it's not going to positive. If the numbers were switched, like this was 1.002, this one 2001, so I'm increasing and I'm going to infinite number, like infinity, a huge number. This is not going infinite. It's decreasing, 2001 to 1.002. So you're going to pick this last one and you round it up, it's 1. Limit x approaches -1 from the left. This is -1, and that's left. Do you see the -1 is undefined, which means there is a hole there on -1. That's a hole. So it means when I go from the left side, this is left side, I'm going to stop here and I'm going to go arbitrarily close. Do you see this is my arbitrarily close 2001? And again, check the difference. It's going really huge difference. It's increasing and very huge. If this is 2001, then you know this is, I'm starting from in this, I'm going in this direction for y values since I'm going from the left. So if this is 1.002, that's 2001. Again, I'm increasing, but I'm increasing a big time. So it's going to go 2001 and I'm going, it means that's infinity, positive. X approaches -1 from the right. This is -1 and I'm going to the right, from the right. So it's again a hole. I'm going to pick arbitrarily close and I'm going to pick this arbitrarily close. And if you check a huge difference between these two, I always check the two numbers, see if it's a huge difference or not. And this is a huge difference, which means I'm going negative infinity because these are negative numbers. limit x approaches 2 from the left and right of f of x. That's 2 from the left and right. X and 2 is again undefined. It's a whole. So I'm going to pick arbitrarily close. X approaches 2 from the right is 0.3. Do you see that? Not that much difference. And if I'm going in this direction, the x's are going in this direction and my y's are going in this direction. So I'm decreasing, but you know now the huge difference. It's 0.33. When I x approach 2 from the right side, again, it's 0.33. So that is 0.33 repeats. Limit x approaches positive infinity of f of x. Positive infinity of f of x. So let me erase that. If we go positive infinity, so I'm going positive infinity in this direction. So check the two numbers. Do you see the numbers are increasing? Like I'm going from 0.334 to 0.998, but not that much difference. Not the difference like this one or the other one that we had previous question. So if it's not that much, pick last number, round it up, it's 1. Limit x approaches -1. Do you see the -1 left and right? -1 is right there, and we already did left and right, which is right there, question B and C. And this is infinity, that's negative infinity, limit does not exist. Even if they would be the same infinities, but you are not same positive infinities or both negative infinities, but still you're gonna go not to real number. So it's gonna be doesn't exist. So does not exist because limit x approaches -1 from the right of f of x is not equal limit x approaches -1 from the left. So the limit does not exist. Okay guys, I'll give you some more examples on this, and you guys practice it, pause it, and work on it. Okay, have a good day guys.